CYP Superhero, a review of the Cytochrome P450 oxidase mechanism by Blake Malek. When evil xenobiotics roam throughout the body, passing freely through the cell membrane, Hero emerges from his enzyme cave in the liver, Cytochrome P450 oxidase, to put a stop to these vigilantes and rid them from the bloodstream. Cytochrome P450 oxidase, or CYP450, comes from a superfamily of enzymes who swore to protect those unable to protect themselves. Without this brave enzyme working tirelessly, keeping the streets safe, the body would have xenobiotics running freely with no one to keep them in check, letting just any drug or medicine waltz across the blood-brain barrier. CYP450 rids these foreign bodies so effectively using its power of hydroxylation of lipophilic molecules, it's almost as if it were made for this job. While made up of alpha helices and beta sheets, this enzyme's true power comes from its Py50 heme protein core, specifically its iron center and its 3+ ferric state. The heme protein consists of 4 nitrogens arranging planarly around the Fe3+, with chiral rings off the nitrogens. These rings are bridged by methane groups to form the planar structure. Cysteine is bound perpendicularly, leaving the 6th bonding site available for elemental oxygen when performing hydrolyzation of the xenobiotics. Oh no, did you hear that? Loud music, people partying, the xenobiotics are invading. CYP450 quickly jumps into action, confronting the xenobiotics on the battlefield, the endoplasmic reticulum of the liver cells. Cytochrome P450 oxidase grapples onto the xenobiotics, holding tightly as it prepares its powerful hydroxylation attack. First, through the support of its CYP sibling, Cytochrome P450 reductase hits the wind out of a NADPH bystander, sending a support electron straight to CYP450's ferric core. With its newly reduced heart, the gods from above deemed the enzyme worthy to wield the elemental oxygen sword. As the sword touches the enzyme's hand, it feels the negative energy being pulled from its body into the sword. NADPH is oxidized once again by Cytochrome P450 reductase, but the energy is now transferred to the sword, preparing it to be unsheathed and ready to strike. CYP450's 2 proton pals grab onto the oxygen sheath of the oxygen sword, pulling it off using a heterolactic dioxygen bond cleavage technique, relieving an unstable and reactive Fe5+ bonded to oxygen. With both of its bonds arms gripping the sword, the CYP450 oxidase plunges into the xenobiotic's carbon-hydrogen bond, creating a polar hydroxy hat. Defeated, this polar cap prevents them from crossing cell membrane walls that surround the body, and the only place left to go is follow the Yellow River, leaving the body forever. After vanquishing his mighty foe, Cytochrome P450 tirelessly watches over the body from the liver, because evil never sleeps. Let's review. The mechanism of Cytochrome P450 oxidase consists of 2 major parts: activation of molecular oxygen and the oxidation of the substrate. To start, the substrate binds to the active site of CYP450 enzyme. Through a P450 reductase reaction, NADPH is reduced to NADP+, and its electron is transferred to iron 3+, reducing it to iron 2+. Attracted by the readily available electron, molecular O2 binds to the iron core, using the electron to form the bond. A second electron is extracted by a second P450 reductase reaction or through a cytochrome B5 reaction. This electron goes to the O2, reducing it. The reduced oxygen is bound to the two protons in a heterolytic dioxygen bond cleavage, breaking into water and oxygen double bonded to iron, which is now at a 5+ state. This intermediate is the most unstable or reactive in this reaction. The remaining oxygen attacks the carbon-hydrogen bond of the substrate, creating a hydroxyl group, and the iron returns to iron 3+. The substrate no longer fits in the active site, leaving it to be excreted from the body, while CYP450 is ready to get back to work.